Today I'm going to review a few composition practice problems. Let's look at the first problem. This problem asks, what is the final transformation in the composition of transformations that maps the pre-image ABCD to image A', B', C', and D'? So we're looking for the final transformation. Well, the first thing that we should do is identify each image. Here we have our pre-image. And we know this is our pre-image because it doesn't contain a prime notation. Here we have our image 1 after 1 rotation. And we know this is our image after 1 rotation because it contains 1 prime notation. And then here we have our image 2. And that's because it's our image after our second rotation. And we know that because it contains 2 prime notations. So we are looking for what is the final transformation. So we know we've had 2 transformations. 1 to go from this pre-image to this image, and 2 to go from the image 1 to image 2. What we want to identify is what we have to do to image 1 to get to image 2. Well, it looks as though we are doing a type of rotation. The reason we know we're doing a rotation is because the orientation of A and D changes. And in a translation, orientation does not change. So we can X out A and B, which say that we have a translation. Now we want to identify if we have C, a rotation of 270 degrees about point B, or D, a rotation of 180 degrees about point B. Well, we know that we have to have a counterclockwise rotation because our rotations here are positive. Remember, counterclockwise is positive and clockwise is negative. So we're looking for a counterclockwise positive rotation. So moving this image counterclockwise, we can see that we actually have a 270 degree rotation about point B. If we were to have a 160 degree rotation about point B, our image would actually look something like this. And we do not have that. So we have a 270 degree rotation about point B. Let's look at the next problem. This problem states that a composition of transformations maps our pre-image to our resulting image after our composition of transformations. The first transformation for this composition is, and we're trying to find out what the first transformation is, and the second transformation is a 90 degree rotation about point X. Well, again, what we want to do is identify our pre-image, what our image after the first rotation is, and what our image after the second rotation is. And again, we know this is the image after our first rotation because it contains 1 prime notation. And this is the image after our second rotation because it contains 2 prime notations. So we want to see what did we do to get from this pre-image to our first image because we're doing our first transformation. Well, what we must do is reflect the pre-image across our line of reflection, which is line M. And so D is our answer choice. Let's look at the next problem. This problem tells us which rule describes the composition of transformations that maps the pre-image to the final image. So again, let's label our pre-image, our image after our first rotation, and then our image after our second rotation. Okay, so what we want to do is identify which of these rules describes the composition of transformations. Well, let's look at option A. A says that we have a reflection across line K. So from our pre-image to our image, we want to know if we have a reflection across line K. And we do in fact have a reflection across line K. And so let's look at the next part. Followed by a translation down. And so we can see that we did in fact move our image 1 down to get our image 2. So we did in fact first complete a reflection across line K and then complete a translation downwards. And so we can identify that A is our answer. Let's look at the next problem. This problem states, which rule describes the compositions of transformations that map our pre-image PQRS to our figure P prime, Q prime, R prime, and S prime? Well, again, we want to label. We have our pre-image. We have our image after our first transformation. And we have our image after our second transformation. Okay, so we want to identify what we would do first. Well, it looks like we have some type of rotation. And we know that we have some type of rotation because it looks like we are completing a rotation about this point right here, point Q. And it looks as though we have completed a rotation about that point. So we know we have a rotation about point Q. Now what we want to do is identify what degree of rotation do we have. Well, it looks like we have somehow gone ahead and moved this segment P and S up to the top. Therefore, we can reasonably assume that we have a rotation about point Q 180 degrees. So that's our first type of transformation. After we complete a rotation about Q 180 degrees, well, then it looks like what we do is we go ahead and reflect image 1 across line L. So we have a reflection across line L. Well, we know when we compose transformations, our rightmost transformations tells us what we do first, and our leftmost transformations tells us what we do last. So when we compose this transformation, it would look like that. And so what we want to do is go ahead and identify which of these answer choices represents that transformation. And it looks like B accounts for that transformation. As we can see here, we have first our rotation about point Q 180 degrees, and then after that we have a reflection about line L. Let's look at the next problem. This problem states, which rule describes the composition of transformations that maps the pre-image to the final image? So we want to again identify where our pre-image is, where our image after our first transformation is, and then where our image after our second transformation is. And so what we want to do is go ahead and identify what transformation we need to complete to get from our pre-image to our image. Well, it looks like in order to get from our pre-image to our image, we need to do a reflection across the x-axis. So the first thing we do is do a reflection across the x-axis. Oops, sorry, 1 second. Reflection across the x-axis. Right? And so we have completed this first transformation. So now what I want to do is look at what we need to do from image 1 to image 2 to create that final transformation. And it looks like what we need to do is do some sort of translation. And how do we know we are doing some sort of translation? Well, we're not doing a reflection because our line segment A and B is not on the same level as our line segment A and B in image 2. And we know we're not doing a rotation because our orientation has not changed. And we're not doing a reflection, which we've just gone over, and so we must be doing a translation. And so we want to identify what kind of translation we are doing. The easiest way to go about this is to count what our translation looks like. So we move 1 unit. We're looking at our vertex A. Our vertex A moves 1 unit, 2 units, 3 units, 4 units, 5, and 6 units. So we have 6 units to the left, and so we have -6. And we move 1 unit up, so we have a +1. So our translation would look like -6 and 1. So again, what we want to do is do our first transformation first. Let our first transformation both be our rightmost transformation, and then our last transformation be our leftmost transformation. So we end up with something that looks like this. And so what we want to do is identify the answer choice that matches this, and we can see that B represents this transformation. Let's look at the next problem. This problem says that the rule is, and here's our composition of transformations, is applied to our pre-image, and we want to know what triangle shows the final image. So we want to identify our pre-image, and then what we want to do is see which of these figures on the top goes ahead and represents this rule of transformations. So here is our composition of transformations. And what we know is that we must go ahead and do our rightmost transformation first and then our leftmost transformation second. Okay, so the first thing we want to do with this pre-image is go ahead and rotate it 90 degrees. More specifically, we are rotating it 90 degrees counterclockwise. And we know it's counterclockwise because we have a positive. So, when we rotate this pre-image counterclockwise 90 degrees, we'll end up in this quadrant. In fact, we'll end up right here where our figure 4 is. So there we have completed a rotation of 90 degrees. And so now we want to do our second transformation, which is to go ahead and reflect that across the y-axis. And so once we reflect it across the y-axis, we will end up here. Okay, so what we did was we went ahead and took our pre-image, rotated it counterclockwise 90 degrees, which brought us about where this figure 4 is. And then once we identified that, we went ahead and reflected that across the y-axis to get our resulting image, which is figure 1. And so our answer choice is A. Let's look at the next problem. Let us look at one more problem. This problem states the parallelogram f prime, g prime, h prime, and j prime is the final image after the rule, and we have our rule. was applied to our pre-image parallelogram F, G, H, and J. So we want to know what are the coordinates of vertex F of parallelogram F, G, H, and J, which is our pre-image. So we want to work backwards to identify what the coordinates of vertex F were on our pre-image. And what we have here is our image 2. So our image after applying these two types of transformations. Well, the first thing we want to do is go ahead and identify what these transformations tell us. Well, these transformations tell us that we first completed a transformation. 1, 2. And so this actually, as a mapping rule, looks like we took our original coordinates, we went ahead and added 1 to x and added 2 to y. So that's the first thing we did to the pre-image to get to image 1. Then to get from image 1 to image 2, we applied the rule for reflection across the y-axis, which mapping rule looks like this. So we keep the x and y coordinates the same, but then we go ahead and negate the x. Well, what we want to do is go ahead and work backwards. So we want to first identify what the F vertex of our image 2 is. And the F vertex of our image 2 is located at 3 and 4. So we have 3 and 4. So F of image 2 is located at 3 and 4. So let us work backwards. So first what we'll do is we'll go ahead and reverse this rule. And in order to reverse that rule is to go ahead and we don't have to switch the x and y coordinates because we didn't do a switch, but we did do a negation, so we would negate back. So we would find out that the F prime vertex of image 1 is at negative 3 and 4. And so now we need to reverse our last rule. This is our translation. And so we would go ahead and find out the F. Well, instead of adding 1, we would subtract 1, which let me put that into my calculator. Would give us -4. And instead of adding 2, we would subtract 2, which gives us 2. So this was the F vertex of our image 2. This was the F vertex of our image 1. And here we found the vertex of our pre-image, which we are looking for. And so we can select D. So all we did was we outlined what this composition tells us to do. And we know we work from our rightmost, so this would be first, and this would be second. And to reverse that, we would reverse our second one first, and then our first one, and then from there we would get our pre-image coordinates. I hope this was helpful, and I hope that you are successful in your independent practice problems. If you have any questions, please reach out.